Okay, let's begin. Hello, and thanks for joining us today for our live webinar on creation of sewer metering areas, or SMAs, for better asset management. My name is Raj, and I'm the Director of Marketing and Client Service Manager with Innovise. And we're really excited about today's webinar. Here at Innovise, we are primarily software tool makers. So we develop software tools for the water industry, water, wastewater, stormwater. And sometimes we are shown by our clients what we envision as the application. So in the sewer field, we look at master planning to capacity modeling, even up to real-time CSO facility modeling. But every once in a while, we're shown other ways and somewhat really impactful ways our clients use our software tools. And I think today is one of those examples. Jim, who I'll introduce to everyone in just a little bit, from Western Virginia Water Authority, really showcases some practical approaches to solving their specific utilities challenges. And he's going to talk about dissecting challenges with their flow meters, revisiting their field data collection practices, taking another look at their model calibration, and much more. And I think it's specific to their utility, but I think it's going to be applicable to many of the viewers on this webinar. So real quick, before we get to the main part of the presentation, let's talk about logistics. The webinar will approximately be 45 to 50 minutes long, and there'll be a question and answer session at the end. Your phones and computer microphones are muted, so the only opportunity to ask questions is via the chat feature, which is typically to the right of the interface. Please send it to all panelists versus just a host or presenter, so we could administer the questions and then compile them and address them in the question and answer session at the end. Okay, thanks. Now on to our speaker. Really pleased to have Jim O'Dowd here with us presenting today. Jim is a professional engineer with over 20 years of experience in water and wastewater consulting. And currently he is the infrastructure asset manager with Western Virginia Water Authority in Roanoke, Virginia. He holds a bachelor's degree in civil engineering from University College Cork in Ireland. And he's also the vice chair of the ASCE Pipelines Division Underground Pipeline Asset Management, UPAM, committee, and also serves on the UPAM Task Committee for Sewer Condition Assessment. He has presented papers at national and international conferences, all with a primary focus on hydraulic modeling and asset management. I personally had the pleasure of knowing Jim and working with him a little bit. He's probably for over 10 plus years, and consistent with his talk today, he consistently brings fresh, practical ideas to the table. And not only that, he understands how to implement them efficiently, and typically does so with a lot of smiles and dry humor. I think people who work with Jim can attest to that. I guess this is a fun fact about Jim. He has 2 boys, ages around 10 and 12, and all 3 of them, Jim and his 2 boys, compete nationally and internationally in traditional Irish folk music competitions. They're all multi-instrumentalists, and it's pretty amazing. I've seen some videos, and it's great to watch. I guess, Jim, with that, I'm going to pass over the controls. Thanks so much again for agreeing to present, and you could take it away.
Sure. Okay, I think I need to share a screen, do I?
Yep. Yeah, I'll give you the controls just now.
There we go. Okay, can everyone see that?
Yep, looks great.
Good to go. Okay. Yeah, thanks for the introduction, Raj, and welcome everyone to the presentation. Now, I will not be doing any traditional Irish music on this presentation, despite what Raj mentioned. But Raj did say I am the infrastructure asset manager for the Western Virginia Water Authority. I joined the authority in late 2008 as they were starting to embark on hydraulic modeling of their system. Now, just to let everybody know where Roanoke is, because some people are not that familiar with us, we're down in Virginia, in the southwest corner of Virginia, about 3.5 hours from Washington, D.C. Now over to the agenda here. I'm going to talk about the sewer metering areas, the definition of those, the methodology, benefits and realizations that we had, and some conclusions. Now a little bit about our organization. We've been in the water and sewer business since about 1891. We serve a population of around 250,000 in Roanoke City, Roanoke County, Salem, Botetourt County, and Franklin County. Let's see. Now, in terms of infrastructure on the sewer side, this is actually an excerpt from our asset management plan that we put together earlier this year. And here you can see that we've got about a total of 886 miles of sewer main. And if you look at the material here, concrete, we have 85 miles of our concrete pipe is beyond its service life, and 62 miles on the clay side. So a total of 148 miles. Now, that equates to quite a bit of needs, and that translates into dollars. So if we take the same 886 miles and break it down by diameter, we see that we have 115 miles of 8-inch pipe, which is beyond its service life. So the horrible figure down here is about $154 million that we need to theoretically be spending, and we've got another $118 million in the next 10 years to think about. So work certainly needs to be prioritized, and as I mentioned, we've 154 million in needs in the collection system. However, this year's budget is only 4.4 million for the annual CIP. So we need to start thinking about where do we start, and it's difficult to understand large systems. Smaller systems are usually easier to manage, so it's good to break them down. So as it pertains to sewer metering or monitoring, our historical approach used to be we would have large sewer sheds and we'd meter year-round, and sometime in April we might get a report from the metering contractor, and various assumptions were being made about the potential use of the metering data. So this is showing one, or actually two, of our old sewer sheds. This one here is the Peters Creek Upper Sewer Shed. There's 26 miles flowing down to this meter. And this is the Peters Creek Lower Sewer Shed, so it flows from here to here and comes all the way down. So meter B was down here, and there was 82 miles in total flowing there. So these sewer sheds have been defined from previous studies. There were around 30 of them. Some were small, at about 20 miles was among the lowest, but most were large. And in fact, some of our meters were collecting like 300 miles worth of flow. So the data wasn't really reviewed in depth. I mean, we would look at it in terms of, were they missing data, where the meter was not working on at a particular time, but we weren't really analyzing it. So the data was to be theoretically used for modeling. Now, some meters have been installed for 4 or 5 years, since 2004. We had purchased InfoWorks CS in 2007, and I began modeling in earnest in early 2009, a few months after I got here. The smallest sewer shed, Barnhart Creek, was the one I selected for initial calibration, and I calibrated it to a summer storm in August 2008. So this is just showing to InfoWorks CS and the subcatchments, pipes, and nodes, which most modelers should be familiar with. Now, in the summer calibration, I was quite happy with myself. I'd got it, managed to match the observed flow with the model flow, so I thought I was onto a winner there. And then I was in for a fairly rude awakening, because I took the same subcatchments that I'd defined and calibrated, and applied a winter storm that occurred in January 2009. It was actually a much smaller storm, but the reactions in the model was completely different. So I was a bit confused by that initially, but I recalibrated to that storm. And this is just showing the 2-year storm for the summer calibration, and this is showing the winter calibration. So again, all I've done here is I've changed the subcatchments in InfoWorks CS. But what we're seeing here is about a 2 to 2.5 time difference in the flow in the model. So That was one of my first eureka moments when I realized that the runoff from the winter storm was found to be 2 to 2.5 times that of a summer storm, which begs the question, why are we bothering calibrating to a summer storm? It's more conservative to model and design to the winter conditions. So with that, the first thing, to the shock of the metering company, was that we decided that year-round metering was now abandoned, and we now meter from October to April. So looking at the modeling too, and talking to staff in the former Wallingford and now Innovize, you know, we talked about how many miles of upstream mileage can one have when you're calibrating, and they were saying, well, in an ideal situation it would be around 2 miles, but I was looking at 20 miles here in my lowest one. So they can't really be accurately calibrated. So a lot of the previous metering data was deemed to be largely useless for hydraulic modeling. And the annual report that I talked about from the metering company, it might have been interesting, but it provided no direction regarding what improvements should be made into the system. So where should we spend our metering budget now? Only areas with upstream mileage of 4 miles or less could be accurately calibrated, and 4 miles was stretching it a little bit. So where are these pipes? We need to define those, and once those pipes are identified, polygons would need to be drawn around them to define the SMA. So what tools should we use? Well, first I'll talk about what tools we actually have. We currently have Infonet Mobile, and InfoWorks CS, which is quickly becoming ICM. So Infonet, I'll talk about that for a little bit. I describe it as kind of a multitasking chameleon. It's the GIS system on steroids. So this is showing our entire sewer system here. And we did have a desire to focus on data analysis rather than on the mechanics of data import and management in early 2009. So a business decision was made to consolidate all the available asset data in one system and also incorporate all of the work order data. So we adopted Infonet and Mobile in early 2009. And the way Infonet works is we can raise a work order here on a pipe repair, and commit that to the system. It goes into the Infonet Mobile scheduler, which the guy in the field can click on one of these work orders here and open up the work order. And in turn, they fill in the data, put in data on the repair or the incident that they're reporting on, and send that back up to the system, and within 2 minutes I can see it here in my office. This is an example of one of our digital forms. So what's in Infonet? We now have like customer complaints, overflow incidents, blockage incidents. We have repairs, pipe repairs, manhole repairs, pipe cleans, and CCTV surveys, GPS surveys, and manhole surveys. So we were able to bring in all of the historic data, which was very useful, and then also start pulling in the other data seamlessly from Infonet Mobile. So one of the first things we did then to define upstream mileage using Infonet is we just use this very simple query right here. It might look a little complicated if you're not used to seeing these, but it's very, very simple really. And we themed the pipes then on the resultant upstream mileage. So you can see all the colors through here. So if we zoom in on one particular area, we're seeing here that this light green is between 4 and 5 miles, and the magenta is between 2 and 4. So, and that's evidenced also by the upstream mileage indicated here. So we've got the upstream mileage, that's great. We see down here at the logical point where you'd be putting in a meter, it's 4.285 miles. So in Infonet we can just click a button and it'll show us the upstream trace. So we just clicked on that, clicked there, created the upstream trace, and the area in red here is that area. And then simply create a polygon around the upstream mileage, and your SMA is complete. So it's really not that complicated. So we continued building SMAs, and after I did about 5, I decided to give it to the summer intern, and he really enjoyed building these. So we ended up with around 257 of these, and we had to make some refinement here. So we ended up, originally I said like we had them, we're going to stop at 4 miles, but we ended up having 55 that were between 4 and 5, like the one I just showed you. We ended up at 48 between 3 and 4, 55 between 2 and 3, and 99 between 1 and 2. So areas with upstream mileages less than 1 mile and greater than 5 miles were excluded. And like I said, the original idea of having SMAs of 4 miles upstream or less had to be expanded to capture more of the system. So right now we have SMAs that are encompassing 636 miles of the 886 miles in the system. That's 72%, 257 SMAs in all. So this is showing our original 30 sewer sheds. In fact, there's the Peters Creek ones I showed you earlier. And this is what it looks like now with our resultant 257 SMAs. Much, much smaller definition on these. So a couple of years ago when I was on that, or still on that committee with ASCE, one of the things we bandied around was approaches to system management. And a couple of us had some ideas on that with, we talked about an rain-derived I&I approach, an asset management approach, and also one that we had proposed, which was a customer service approach. Now, the RDII approach focuses on identifying and reducing I&I and necessitates an emphasis on source detection, flow monitoring, lateral inspection, smoke testing, that kind of thing, to find where the I&I is coming from, if there's any smoking gun, or golden hole, as it's been called in other places. So the asset management approach, completely different. It's looking more at strategic pipelines and risk assessment. So with that, you'd be radiating out from your outfall or your treatment plant at the bottom of the system, normally the larger pipes. Because the concept there is that if the pipe the 60-inch pipe that's coming into the treatment plant fails, well, everything else is going to fail as well. And that obviously would be rather catastrophic. The customer service approach stresses more the social and regulatory action risks and addresses causes of known issues, such as historic overflows or problem areas. So the goal here would be to study the area and determine what the cause of the issue actually is and rectify that issue through either maintenance or replacement. So while all three approaches are valid, we found that the customer service approach is the driving factor in the use of SMAs. And from the customer service approach also, we can prioritize the RDII investigations in specific areas. Now, in terms of the asset management approach, yes, we completely agree large diameter pipes are critical, and a certain percentage of our budget should be allocated to cleaning and televising them. But in terms of flow monitoring is not needed at all for that, in our opinion. So going back to an image I showed you earlier, we're looking here again at this SMA that we created earlier, and we see customer complaints, blockage incidents, and overflow incidents. And we determined that really it's overflows and blockage incidents really are the ones that are affecting customer service and also getting into the paper. So using a theme in Infinet, we were able to further refine this between dry weather overflow incident or wet weather overflow incidents. And then we have our SMA, we've got this polygon, and what we can do now is we can populate fields in that SMA by applying queries. Now again, very, very simple query in Infinet, because all the data is there, the background data, with the incidents and the blockages and the complaints. So this is a grid view of the SMAs. I was showing you the map here earlier, but again, we can categorize various factors on the SMA. So what do we do in terms of ranking them? Well, we normalize the respective incidents per mile by dividing the number of incidents by the upstream mileage. Again, very simple calculation. We could do it with a query. We experimented with different rankings initially. We were thinking, let's do it all in wet weather overflows, but we decided later to change that to a balance of normalized wet weather overflows by 70% and then blockage incidents by 30%. And then the ranking, was just worked out by sorting descending in this field. So here you can see it's a SMA 3, which means it's between 3 and 4 miles. Its ranking in 2013 was 1. We got the upstream mileage, number of dry weather overflows, blockages, normalized blockages per mile. The wet weather overflows 56 here. And then we did that combination, and then, like I said, here 11.349 was a normalized value. So just sorting descending on this, we were able to get our ranking. So this is our most problematic SMA here. And I've stripped out the incidents so to make it clearer. So using a label in Infinet, I've got the mileage, the ID, number of blockages, number of wet weather overflows, and also included in here the number of pipe repairs, manhole repairs, CCTV inspections, pipe cleans we've done, normalized blockages, number of customer complaints, number of meters or connections, and then the ranking. Okay. Now, this is our least problematic SMA. Similar mileage, 3.875. But as you can see, we've had no blockages, no overflows, no repairs. We've had 2 CCTV inspections, and we've got 143 connections on there. But the rank is 254. And this is exactly what we were trying to get to, that when we had to go down to upper management and say, and explain why we're going to spend $25,000 a year on a sewer meter, I would feel much more comfortable showing them this particular SMA and saying we were justified in putting a meter here, rather than explaining after the fact that, well, when we found out after the fact, yeah, there was nothing going on here, there was no need to do it. Okay, so we did internally broach this SMA concept, and I gave a similar presentation to this one I'm showing now with our department managers and explained the key concepts of the upstream mileage and the SMA generation. And we talked about the value of the prioritization of work within these SMAs. And the idea was adopted. So right now, when we're working on an SMA like that worst one I showed you earlier, the resources are focused on the SMA, and all personnel in engineering, in our field operations group, and our investigative group, they all understand that that's the priority, and we're coordinating the work together. So initially we'll do inspections, we'll send out our GPS crews, manhole survey crews to update the asset geometry and elevations, dimensions. We'll also do CCTV work out there. And now if issues are discovered during that process, repairs or pipe cleans are scheduled for remediating that. And any incomplete work orders that we have in the system, they're prioritized initially by upstream mileage for pipes greater than 5 miles, and then by SMA ranking otherwise. So I'm going to talk for the rest of the presentation here about the Spring Road SMA. Now, this one had a ranking of number 3 in the system. 46 wet weather overflows, mainly occurring right here, and it's, by the way, it's this SMA here I'm talking about. 297 meters. So quite a lot of problems going on here. So one of the things I started doing is putting together an SMA analysis report. It's about 5 or 6 pages long, and it just forces me to really think about what's going on in the SMA and actually document it and come up with some preliminary plans. So we do need to step back a little bit from the data once in a while and look at the project area as a whole. You know, is the area in need of just a few pipe replacements, or are there opportunities to improve more than just one specific condition? So these were the overflows I referenced a minute ago, and the SMA would stop right here. But we also had more overflows here. We had these pipes here are directly adjacent to buildings, and we had some undersized pipe. So this is footage or photos of actually the overflows that I'm referencing. This is a manhole that's around 2.5 feet from a building, and another one that's around 3 feet. So clearly there's a few issues going on in this area. So there were 3 SMAs here. This is the one we originally started with. And again, overflows all the way through here. So it was determined to install 4 flow monitors in this area, incorporating those 3 SMAs and then a downstream location right here, just to capture everything and see, how are the flow meters working together. I mean, are we getting the same flow here that we'd expect to see from all the sum of these 3? Okay. So we identified the sites. We televised the pipes and manholes were inspected and surveyed just to make sure that everything was all right. We installed the meters for 4 months. We had 2 minor rain events and then 1 large event. So we did our hydraulic model calibration, and those of you who are familiar with InfoWorks CS or ICM may recognize these subcatchments here. This is from the hydraulic model calibration report I prepared. This is the SMA in here, this area, and the monitored pipe was here, and you can see the calibration here between the observed and the model flow. Now, this is showing the calibration for this point down here, where all of the 3 SMAs and the adjoining contributing smaller areas, which were not in SMAs but less than 1 mile, were contributing. And we did see that there was a very bizarre peak here and flattening out, which we couldn't understand, because in the model was thinking that the flow would actually peak at about 2 mgd. And if I go back 1 slide, you'll see it was almost, just to this point, it was almost 0.8 mgd, but it was only 1 mgd for all this. So what we found actually was that there was a blockage further back here in a pipe that was causing an overflow that we weren't even aware of. So again, the value of modeling was wonderful at times. So I'd also done some literature review on rehabilitation studies, and what literature seemed to be saying was that rehabbing pipes and manholes in an area is estimated to reduce I&I by 30%. Now, adding the rehab of service connections all the way to the structure, not just the property line, but all the way to the structure, is estimated to reduce I&I up to 70 to 80%. So that's with the 2 of them, both manholes and pipes and the service connections. So what does that actually mean in terms of dollars? Well, that's about $2 million in that SMA. So here is another view of that SMA. It's got a different theme. I'm actually showing the CCTV and the manhole surveys and everything else here. But I've got similar data here that I showed earlier on this SMA, where I've got the mileage, number of wet weather overflows, and the ranking. But I've also populated this, again using a query, with the number of manholes, number of vented manholes that are subject to sheeting or ponding, which came from the manhole surveys, number of brick manholes, again from the condition surveys. From the model, I see the dry weather flow and the peak wet weather flow, and then the resultant factor between the 2. And I did some calculations here based on if we replace the vented lids that we had here, the 34 vented lids, so $25,000. The cost to line the manholes at $200 per vertical foot, assuming we're lining all 70 of the brick manholes, was $79,000. The cost to line the pipes at $60 per linear foot was around $1 million, and then the cost to replace the services at around $2,500 each would be about $750,000. So the total cost is around $2 million to do all of that work. So that's quite a lot of money to invest in just 1 SMA. So we now have our calibrated model, and what do we do with it? Like, what do we design for? Is it a 2-year storm, or what should we be doing? So one of the thoughts I had was, if all that flow could be contained in the system instead of overflowing, how much flow would that be? So it might be a bit of a crazy concept, but this is showing here the initial model run with a regular pipe size. And this is the flow that's coming into the wastewater treatment plant. So it's peaking at around 170, 175 mgd in the 2-year event. So I doubled every pipe in the system in the model, just for grins, and it peaked all the way up to 800 mgd. Now, let me say that our treatment plant can take around 200 mgd on a good day. Now, at the local level, looking at that same problematic area of that SMA, this is showing with regular pipe size what's going on. In fact, the flow is going they're up the pipe to escape. It's going the wrong direction in the 2-year event. But when I double the pipe size, it's peaking to 4 mgd for a very short period, and then it's going back down to 2 mgd. So, in discussion with a few people, we were talking about perhaps designing for this shaved peak. Like, don't really consider this too much, but let's consider designing for this. So, in general, and with the debate between rehabilitation versus conveyance, well, conveyance is obviously not the global answer for a multitude of reasons, because it would exceed the plant capacity dramatically if all I&I flow was conveyed. And clearly I'm not going to suggest to management that we double the pipe size of every pipe in the system, because I'd be looking for a job pretty quickly. But conveyance is more cost effective to address the local issue and to relieve overflows. So we do have some low-hanging fruit here with those vented manholes I talked about, the 34 vented manholes that are subject to sheeting and ponding. Well, that might go a little way to removing that peak that we saw in the model. And then the brick manhole rehab, that'll also hopefully treat the peak. And we're also investigating pipes with possible storm connections from smoke testing. But the conveyance project will deal with that shaved peak. So the original CIP project that we had considered was upsizing some of this pipe here. And then as we looked at it more further, and this is the slide I showed you earlier, with the pipes adjacent to the buildings and undersized pipe, and the fact that we're seeing overflows down here as well, we thought we'd better expand the project. Because what I found is that if we do increase the pipe size here and here, and don't deal with this, well, all that's going to happen is that flow is going to overflow here rather than here. So this is a shot from the model, and it's showing the 2-year event with our current infrastructure. And this is the shaved 2-year event with the proposed infrastructure, where I've increased the pipe size from 8 to 12, and in some cases 18 inches here. And by and large, with the exception of this area down here near the interceptor, the flow is staying within the pipes. And this area is an area that we're actually redesigning anyway to so that we will not see any kind of overflow here. So the resultant project here is we're going to pipe burst, do conventional replacement, and then this is all new construction because we're going to be pulling the pipe and abandoning the pipe that's adjacent to the buildings and pulling it out here into the backyards. And we're going to then pipe burst and then more conventional replacement. So the evolution of this, we started with the import of the incidents into Infonet, and then that's again coming in all the time into Infonet now from mobile from the field. We created and populated the SMAs. We did some ranking and identification of problem areas and established the objectives. We also then we did the flow monitoring based on that, did hydraulic modeling, and now we're on to project design and hopefully the resolution of those issues. So with our current practice, we install about 15 meters at a time, and our hope is to move those meters after 3 significant events. Our goal also is to try and meter 30 SMAs in a season, and that doesn't always happen. Mother Nature doesn't always cooperate with that. In fact, last season we had the meters in the same place for 6 months. But the key thing here is that the data is actually used. And even though sometimes I can't stand it, I force myself to create an SMA calibration report every single time because it forces me to really think about these areas. We also do a modeling study and a CIP report. So this is showing the calibration report I do. And again, this one's actually about 10 pages long. But it's something that's easy to follow for most of our peers here. And again, like I said, it forces me to actually consider what's going on in the area. So in conclusion, We feel that the SMAs are relatively easy to create. I mean, you could do it with any kind of GIS system theoretically. The methodology is relatively simple and defensible. It can be explained to upper management, to board members, and I've yet to meet somebody that didn't understand it. It streamlines the model calibration and the understanding of flow characteristics. And I would recommend having somebody dedicated to that within the utility, because having that person that is handling all of that information, it's useful to have that one point of contact. It focuses multiple departments on the same area, so they're not going back to they're not scattered throughout the system. They're actually focused on the same area, and each one is helping each other. It also facilitates prioritization of investigations and projects. So I did write a paper on this. It's a 6-page paper via PDF, and I'd be happy to send that to anybody who wants to see it. And my email is at the bottom of the screen there. But that is actually the end of my presentation, and I'm probably quite a bit earlier than we thought we were going to be, Raj.
No, that's fine.
But I'll throw it over to you if
Sure.
there are any questions have come in or any discussion.
Sure, sounds good. Yeah, thanks, Tim. Great job. And there are a handful of questions, and I'll just take this opportunity to have the audience fill out any questions as after they view the presentation. Please relay them through the chat window, and we'll address them in a few minutes. We'll go through some next steps and other resources slides in just a bit, and then we'll get right into the Q&A portion. Okay, so please feel free to enter in any questions through the chat window. Thanks. Okay. So again, thanks, Jim, for doing a fantastic job of kind of really pushing some of the software tools and some of the concepts in your organization. I think we're really excited within Innovise internally. We've talked to many other utilities that are very keen on this idea of SMAs. And I know you also handle on the water side, so I'm sure that's probably for another topic. But this similar types of concepts certainly have been widely used on the water side with DMAs and looking at kind of setting up those mini zones there. So it's very neat to see the correlation on the sewer side. So just real quick, just to take a couple minutes to talk about potential next steps. We have recorded this webinar, and Jim has graciously approved to have his presentation files emailed out. So once this is finalized, in the next couple of days, we'll send those to all of the attendees on this call. Feel free to contact us with any questions or comments that came up today on our tools, and Jim relayed his contact information as well. And we do have the next webinar is on, I guess, any utilities or consultants on the line that are using AMI or AMR smart meter systems. We have the next webinar. It's just a short one. It's a 30-minute long webinar titled "Demand More from Your Smart Meters" with Innovise's Demand Analyst tool. So that's something if you guys have clients that are using it, or if you are using AMI, AMR, or even any type of meter, smart meter system, it's a great way to process that data and actually use it for other locations, particularly the hydraulic model. Okay, so that registration is open, and some other resources for everyone. Innovise Forums is, you'll have the web link, and we'll send this out so you have the direct link, so you don't have to copy this down. We also have a multitude of videos on our Innovise YouTube channel, and it's going to continue to grow. Eventually, we're going to have some of these recorded webinars up online on that channel, so please take a look. And then there's a lot of great, on a daily and weekly basis, we have a lot of great blogs on the Innovyze blog specific to all of our packages. And so you can sort by the category and review previous blogs and search for any questions you may have. And there's a good chance that it'll be showing up in the blogs or one of our forums. And then lastly, if you have want to set up a meeting, phone, web, or in person, we have client service managers throughout the country and throughout the world to assist your specific region, and that's the link there. So let's go now. I'm going to stop sharing, and then I'm going to take a look at some of these questions, and then I'm going to pass the controls back over to Jim and see what we could address in the next 5 or 10 minutes. Okay. All right, so Jim, let's see, we have a few questions that came in through while you were presenting, so let's hit some of those first. One was a question, you used the term upstream mileage to describe SMAs. What would be your definition of upstream mileage? What exactly does that encompass?
It is essentially everything that's flowing down to, let me get there, everything that's flowing to a point here. There we go. So, for instance, there we go. So, for instance, here, the upstream mileages would only be about, 400 or 500 feet. But as we get further down here, down to the outlet of this SMA, there's 4.285 miles flowing to this point. So that's the mileage that's upstream of the metering point.
Great, thank you.
Sure.
All right. There was another question. There was a couple questions about the SQL queries that you showed.
Yep.
And one of them was, is that something that you already knew how to do, or would the average GIS technician know how to do them? Also, what type of team do you have to help with this process? You mentioned an intern. What other staff was available to help you accomplish this task?
Sure. I think the query stuff is fairly easy. In fact, there's quite a lot of information in the help in the Infonet product on this. But once you get into it, it's not that complicated. I mean, it's just, looking at this one here, which is defining upstream mileage, I just set a user number equal to the length divided by 5280, and then added that number, kept on adding that number to the length. So it's really not that complicated. It's something, as a hydraulic modeler, it was not something I had really dealt with before. But after some, initial tinkering with SQL queries, it really wasn't that hard. And I think actually Innovyze has a few presentations on the use of SQL queries, which are beneficial, and they're far more complicated than what I'm showing you right here. There's amazing things you can do with these things, but I'm only scratching the surface. But yes, the average GIS technician could do that. In terms of the team working on this, I've got two main technicians reporting to me, and they have around 6 or 7 interns between them at various times. They increase in the summer and then decrease as they go off to college. But the team working on this, it was really, I started the concept and generated, the first few SMAs, but our summer intern he was done with generating all 257 after around, let's say, 2 or 3 weeks. It was not that long, and he wasn't even working full time. And then after that, then it's just a matter of applying queries to populate the data. Now, one of the struggles that I think a lot of utilities may have is actually populating the system with all of the, with the incidents. If you don't already have that in the background of your GIS, that's going to take some time to bring that in, associate it with the right asset, because a lot of the CMMS systems are address-based and they may not be asset-based, so you may not have that link between the asset and the incident. So we did a lot of work as we were implementing Infonet to create that association. So by the time we started doing analysis again, which is one of the reasons we adopted Infonet, we're now able to actually analyze this stuff. It was really simple to just apply a query and and populate the fields with the incident data.
Gotcha. Yep. No. Great. There's actually a couple questions on that. If there was some of the mechanics or particulars on creating those boundaries, so I think you've addressed them there.
Okay.
Right. Yeah. And other thing regarding the SQL queries, one thing that that's something that's actually on the blogs, the Innovyze blogs, specifically for Infonet and InfoWorks. The technical support technicians from Innovyze post their queries. So these queries that Jim's done, that other utilities have done, can be shared across utilities and consultants, and just basically copy and paste. So it's there may be some massaging based off of how things are labeled, but for the most part, you could actually you don't have to recreate the wheel each time you want to do this. You can kind of put an inquiry into our support, or we may be able to have something already handy just for folks that are looking for help with the SQL queries. All right, let's address some other questions. I'll hit some quick ones, I think. Jim, does Western Virginia Water Authority own the flow meters?
No, we don't. We wrestled with that one when we changed metering companies, and it almost looked like you'd need a full-time crew maintaining the flow meters. So we decided we went out to bid on getting metering companies, and so the metering company owns the meters and they supply us with the data. So they're responsible for the maintenance of the data, and we have found that that's easier. That there's a few, we've got a few sewer depth sensors that we have that we've been experimenting with, and we've got a few of our own rain gauges. But and I will tell you that having experimented with those, it does take a lot of time to get them right and make sure that the telecommunications are working and troubleshoot issues. Originally, I was thinking, we should be able to do all this ourselves, and we've got 260 people working here. But the expertise needed, I would now suggest to people that hire external companies.
Okay. All right. Thank you. This is, feel free to table any of these if you want to take any of these questions offline, Jim, but this one was
sure.
Specific to model calibration and flow monitors. One of the slides shows some of the smaller SMAs that are immediate along the interceptor.
Yep.
One of the questions was, how are those addressed during calibration due to sometimes there's a margin of error with the flow monitors when you're monitoring large flows? Was any considerations taken there?
Well, repeat the question again.
Some of the areas that are smaller and immediately along the interceptor,
yep.
How are those addressed during calibration, taken into account the margin of error from the flow monitors with monitoring larger flows?
In terms of the impact of the interceptor on the
I guess in terms of the calibration, how did that the calibration, some of those smaller SMAs along that interceptor, did you have to finagle with them more than the others that are a little outside of that area?
Not necessarily, no.
Okay.
No. I mean, that was one of the concerns that, like this particular SMA here was, the outlet pipe is here, and it's, I think it was around 1.4 miles upstream. but we didn't have that much difficulty calibrating to that one. Um, and the rest of them seemed to line up pretty well with the calibration, so that when we got to the outlet here, it made sense. Like everything that was contributing from the other 3 flow meters made sense with what was seen in flow meter leaving here.
Okay, great. Let's see, another one. I think there's another one with calibration. Is the calibration for the ones that have been complete, are they good enough for recommending improvement work, or do they have to be validated under wet weather conditions?
No, I mean our approach is we're shooting for at least 3 decent rain events. So I consider these SMAs that have been monitored and modeled, that they are calibrated and they are ready for full design work. Yeah.
Okay.
I mean that was the goal. I mean if you don't achieve that goal, then there's sort of no point. That's the whole point of doing this.
Sure.
Right. And anything I'm showing here, we consider it's calibrated. Once I write that calibration report, it's I'm essentially saying that it's good to go.
Excellent. Okay, great. All right. So out of the various data sources and tools you've used, you mentioned CCTV, flow meters, customer complaints, a hydraulic model, etc. Is there anyone that sticks out as being the most valuable, or which one kind of is on the top of your list, or is there one?
I would say that seeing everything together in Infinet really, really helps, because I probably won't find that slide. Well, this one might do. But the fact that you can see all of the overflows, and of course that's our focus here, but the fact that you can see the concentration and the number of overflows in one view, and also you're able to populate this SMA with tons of different information, you see it at a glance. The background work to pull all that information in, it does take some time, but it makes the analysis so much easier. So I would say having Infinet and being able to see the data is huge, because theoretically you could look at this and say, maybe we don't even need to do flow monitoring. If you weren't that concerned about the hydraulic model, and you could almost empirically look at this and say, well, let me upsize all this pipe. So you could achieve that. You could do very, bare bones analysis, but based on the what's going on in the area and in the system. So that'll be the primary one. But it's one of the key elements here as well is, making sure that the people in the field are assigning the incident to the correct asset. So again, that's a key factor for us in having mobile, that they have to associate it with the correct asset. And it's not address based, so it's not floating around in the system. It's not between these 2 areas here. We know it's right here at this point. So training the field staff, which at times, initially there was some apprehension on their end, but after a few days of using the system and understanding and seeing the context of their work, they took a lot of pride in recording the data properly, and really they are the backbone, and the information they provide is the backbone of what we do now, of any analysis we're doing.
Great. We probably have time for one more question. There's some other questions that came in that are fairly specific on specific products and companies use, but we'll probably answer offline, and Jim will help out with that. But so let's do one more question, kind of following up from the last one, is is somewhat of a newer type of concept, breaking these down. So what was, I guess, getting this across to the different departments? You mentioned, everything from investigations, engineering, planning, to customer service, upper management. Was there challenges getting the idea across and then implemented? It seems like it's widely implemented now. And was there any departments that were slow, or any recommendations to make to kind of help move this along, this concept along?
No, we didn't really have too much resistance. I mean, everybody got it as soon as, like when I showed them the slides of the, which I showed earlier, of the most problematic SMA versus the least problematic SMA, everybody instantly understood, well, this is where we need to be doing our work, or ones like it. So there really wasn't much of an issue there. Some of the departments already had a lot on their plate, in terms of some of the repairs that they had. So, and again, a lot of what we do in every utility is based on the tyranny of the moment and what customers are calling, reporting issues. So there is a bit of a balancing act there for a while, but when we get a little bit of calm, or when we did get a little bit of calm, we were able to say, all right, we're now going to address these repairs systematically, do them in the worst SMA first, and then keep going. But generally, I mean, it's been fine. Like, we haven't had any. There's nothing has occurred to date, and we've been doing this now for about 2.5 years. Nothing has occurred to date that's made us rethink this process.
Gotcha. Okay. All right. Hey, thanks again, Jim. A personal request. Can you just take us out on a few measures of your favorite traditional Irish folk music song, and then we'll just call it a day.
Well, Raj, if you can remove our annual maintenance for 2 years, then
okay.
Yes, I will do that.
So
that's a no.
Okay.
Nice try, though, sir.
Sounds good. Well, hey, everyone, thanks for attending this webinar, and really appreciate your attendance. And any feedback you have, feel free to relay it our way. We'll follow up with the presentation files, handouts, Jim's contact info, and paper, a whole bunch of good resources for you. Again, thanks so much. Have a great day. Bye.